I'm going to be showing off our implementation of RDT 2.1 as part of the RDT programming assignment in networks. This is joint work with Ben Holmgren and Ryan Hansen. I'm Ben Holmgren. So to start off, I guess I'll just demo our implementation with no corruption in the packets. So I'll run our server, I'll run our client, and as we see, we're converting everything just fine. We're only sending ACKs over here. For some reason, we're sending one NAC. Looks like on the last one. Oh, it's probably a timing thing. But yeah, but as you can see, under no corruption, we're correctly converting all of our messages into Pig Latin. So that's us running with no corruption. Let's maybe think about changing this to give it some byte corruption here. And importantly, we are using a modified packet class to send ACKs and NACKs. What we're doing, we're actually just using these variables that were kind of given to us, the class variables with the sequence number and also the message string. So we're using this message string to tell us whether or not the message is an ACK or a NACK, and then the number to know the sequence that the packets are coming from. And we're just using, for the message, we're sending an A for an ACK and an N for a NACK. So that's how we're actually doing it. Now let's run it, let's see, with some corruption. So let's say, yeah, a quarter probability of byte corruption. Let's try this again. So, okay, great. And so now what we see is we end up sending, well, first and foremost, we're correctly doing this. So here's, let's see, here's where we ran it here. Make this bigger. Okay, so we ran it down here, and we see, first off, yeah, everything is right. All of our Pig Latin is being correctly converted. And also, importantly, we can see what the client is sending over to the server. So here we're sending ACKs, it looks like, and then eventually we get a corrupted packet, so we have to send a NACK. And then on the last one, we're sending a bunch of NACKs. But then if we look at what the server's doing, whoops. Maybe, yeah. If we look at what the server's actually doing, what's going on? Well, we're sending, first off an ACK, we're all good. Then another ACK. Then we get some issues, so then we have to start sending some negative acknowledgments, and then eventually we're able to send an ACK again once we get a packet that's correct. And then we send another ACK here. We didn't have any corruption. Here we had corruption, so we sent NACKs until we didn't have corruption anymore. And again with the last one, we also from the server we sent NACKs until we didn't have corruption anymore. So that's our implementation. Let's see. Oh yeah, so we definitely deliver data under no corruption in the network. We use a modified packet class. Remember, we're just using those class variables based on sequence number and based on the message string. And then we do not deliver corrupt packets, right? We looked at the output, and indeed it's correct. And then we also send NACKs. Yep, so we're printing when we're sending NACKs. We're doing that just by sending a message string of N. Here we're just sending a message string of A. And then indeed we resend data following a NACK. So if we look at our print statements from the server, so here's an example. We have to send a NACK, and then after that we resend the data. Well, actually all of these we're resending the data after a NACK. But then, like, say for this example, we send a NACK, and then we still have something that's corrupt, so we send another NACK, and then eventually we get something that's right, so we send an ACK, and then we get our message. So thanks for watching. This was our implementation of RDT 2.1, and I know that Ryan will knock it out of the park with our implementation of RDT 3.0 and 3.1 as well. So thanks for watching.